previous sessions, we have studied about the polymers, their basic concepts, the polymers used for additive manufacturing, classification of polymers, and polymer processing. Now, in this session, we will study about the powder metallurgy because the metal powders are useful in the discrete particle based additive manufacturing systems. So this the syllabus of powder metallurgy, it consists of general concepts, powder production techniques, characterization techniques, microstructure control in powder, powder shaping, sintering, structured property correlation study, and applications of powder metallurgy. So in the general concepts, we need to study about the introduction and history of powder metallurgy, present and future trends of powder metallurgy, and under the powder production techniques, we need to study about the different mechanical, chemical methods and automation of powder and other emerging processes. In the characterization techniques, we need to study about the particle size and shape distribution, interparticle friction, compression ability, powder structure, chemical characterization, etc. And in the microstructure control in powder, so we need to study about the importance of microstructure study, microstructures of powder by the different techniques. Then in the powder shaping, we need to study about the particle packing modifications, lubricants and binders, powder compaction and process variables, etc. And in the sintering, we need to study about the theory of sintering, sintering of single and mixed phase powder, and liquid phase sintering, modern sintering techniques, etc. And in structure property correlation study, we need to study about the modern sintering techniques and the defect analysis of sintered components. And the applications of powder metallurgy involves filters, tungsten filaments, self-lubricated bearings, porous metal bearings, etc. So, we'll move to the first topic in powder metallurgy, that is general concepts. So, the general concepts involves the study of powder metallurgy, history of powder metallurgy, present and future trends of powder metallurgy. Powder metallurgy is the process of producing metal powders and making finished and semi-finished objects from mixed or alloyed powders with or without the addition of non-metallic constituents. Powder metallurgy is a metalworking process for forming precision metal components from metal powders. The metal powder is first pressed or nothing but compacted into product shape at room temperature. This is followed by heating, that is called sintering, that causes the powder particles to fuse together without melting. The powder metallurgy is a highly developed method of manufacturing, reliable for ferrous and non-ferrous parts. It is made by mixing elemental or alloy powders and compacting the mixture in a die. The resultant shapes are then sintered or nothing but heated in a controlled atmosphere furnace to bond the particles metallurgically. So powder metallurgy typically uses more than 97% of the starting raw material in the finished part, making it an energy and material conserving process. The figure below, it shows the metal powder, and it has been brought to the required shape by using the powder metallurgy technique. And the next is, so why powder metallurgy? The parts produced by powder metallurgy have adequate physical and mechanical properties while completely meeting the functional performance characteristics. The cost of producing a component of a given shape and the required dimensional tolerances by the powder metallurgy is generally lower than the cost of casting or making it as a raw product because of extremely low scrap and the fewer processing steps. Parts can be produced which are impregnated with oil or plastic or infiltrated with a lower melting point metal. They can be electroplated, heat treated, and machined if necessary. The rate of production of parts is quite high, a few hundreds to several thousands parts per hour. So, this is the importance of the powder metallurgy, why it is needed. Next, we will study about the general steps in the powder metallurgy process. So, the powder metallurgy process consists of 4 major steps. The first one is production of metallic powder, and then the second one is mixing and preparation of powder. The third one is pressing of powder to the required shape, that is nothing but compacting. Then the fourth one is heating or sintering of the compacted powder at a relatively high temperature. So the process of powder metallurgy, it is shown using a flow chart in this slide. So in the process, it starts with the elemental or alloy metal powders. So it is mixed with some additives. The additives are some kind of lubricants or binders. The elemental or alloy metal powders mixed with the additives, they are blended. They are mixed properly with a mixing equipment, and then that the mixed material, it is sent to a die where it is compacted by applying some force, and then the compacted material, it is then sent to the heat treatment process, that is called as a sintering process. In the compacting, die compacting, the compacting, it is done at a room temperature, whereas in the sintering, the heating is done at the higher temperatures. Then the sintered product, if it is necessary, it can be sent to a secondary manufacturing process or the secondary finishing process, which is optional. If it is required, it is sent for either the secondary manufacturing or secondary finishing process. and then the finished product is obtained. The product obtained is a powder metallurgy product. The same the process it is shown with the help of this figure here by using a base powder and along with the binding and lubricants. It is sent to a mixing equipment. So here the metal powder or the alloy powder, it is mixed in a mixing equipment. Then it is sent to a pressing equipment. So that is a compacting device where the pressure or the force is applied to make the powder compact, and then that product it is sent to a sintering equipment where it is heat treated, and then it is sent for the secondary operations if required. These secondary operations, it may be a machining, it may be tumbling, or it may be the impregnation with the oil. So any one or more of these operations they are performed, and then the final product is obtained. So this figure it shows the sequence of operations. Then the production of the powders. So what are the widely used the metal powders and alloy powders which are mentioned here? Under the metal powders, many metal powders can be used in powder metallurgy. Out of them, a few are mentioned here: aluminium, antimony, beryllium, bismuth, cadmium, cobalt, copper, iron, lead, molybdenum, manganese, zinc, tungsten, etc. Nickel, tungsten, tin, titanium, etc. And under the alloy, aluminium, iron alloy, brass, copper, zinc, and nickel alloy, nickel, chromium alloy, nickel, chromium, iron, nickel, copper, nickel, iron, silicon, iron, solder, stainless steel, composites, carbides, nitrides, etc. So these are the powders which can be used in the powder metallurgy. Then we need to study about the history of powder metallurgy. The metals with a high melting point such as iron entered the scene about 7,000 years before furnaces capable of reaching temperatures close to the melting point were available. This implies that objects made of iron were built using powder metallurgy, which was introduced by Egyptians about 5,000 years ago. The ancient Incas made jewelry and other products from precious metal powders. The smiths of India produced the famous Delhi iron pillar, which is a non-rusting one. So it was weighing about 6.5 tons. Even the other objects even larger than the Delhi iron pillar were built as early as 300 AD in India. Powder metallurgy principles were also used by the Arabs and Germans about 1000 AD to make their high quality swords from iron powder. Tungsten filament used in bulb was produced around 1900 AD, and the subsequent development includes the production of contacts and electrode materials, sintered porous bearings, cemented carbide tools, a wide range of electrical and magnetic materials. They make use of the powder metallurgy techniques. And also, recently, a large number of automobile drivetrain components were produced using powder metallurgy. So next we'll study about the present and future trends in powder metallurgy. Traditionally, powder metallurgy has been based on two major industrial sectors: ferrous precision parts and hard metals. Both of them rely heavily on the automotive industry with focus on internal combustion engines. Today, there is an increasing trend towards alternative drivetrain systems, and powder metallurgy faces the challenges to find new applications to replace those lost with the decrease of classical internal combustion drives. Main strength of powder metallurgy lies in its enormous flexibility regarding materials, geometries, processing and properties. This enables powder metallurgy to adapt itself to changing requirements in a changing industrial environment. Examples given are the powder metallurgy parts in alternative drivetrain systems, new alloying concepts, and processing routes offering the distinct advantages for the powder metallurgy. A particularly wide area is found in functional materials which range from components for high power switches to the fuel cells. Soft and hard magnets can be produced by powder metallurgy with good properties. Metal injection molding (MIM) is gaining further ground. Examples in the medical area, which is a fast growing field. And finally, most of the additive manufacturing techniques are powder based. And here, the knowledge in powder handling and processing available in the powder metallurgy community is essential for obtaining stable processes and reliable products. So this is the first session regarding the powder metallurgy. In the next session, we will study about the powder production techniques. Okay, thank you.